Dear students, today we are starting with the next lesson, lesson number 2, using table buffering. As you all know about this buffering is a temporary storage in which the data can be stored temporarily. Now this table buffering is also usable in case of transparent tables. This buffering allows you to fast the process of accessing the records from a table. Now starting with the next slides, you can see this is a procedure of accessing the data using the buffer. And this is also called table buffering. This table buffering increases the performance when the record of the table are read from the database. Generally, this buffer resides locally onto the application servers. This is an application server and this is our database server. During initially data is read from the database, generally the query is executed firstly directly to the database. Thereafter, the data is loaded into the buffer and accessed directly from it. This whole procedure will speed up of accessing the data from this database records. You can see from this figure there is a SQL query which is executing by the ABAP programs in which we are accessing the table as book from the database. Initially, when the data is reading from the database, it is interacting with the help of database interfaces. That means the query which will be executed onto the database, that will be passed by the database interface through the network. Now this query will be passed through the network to the database server initially when the data is read from the database. Then the database server process this query and return the result back, not to the client directly. It will send this data directly to the table buffer, so that the next time when the client will access the data from the database table, then firstly it will consult with the table buffer, not directly with the database server. This was the procedure of data accessing using the buffer. One more thing that I want to tell you here about this table buffering. This table buffering increases the performance when the record of the table are accessed again and again. And we have mainly three types of buffering. The first one, types of buffering. We have three types. The first one is full buffering. Second one is generic buffering. Third one is single record buffering. Now what is full buffering? When you access a record, all the records of table are loaded into the buffer, then this type of buffering is called full buffering. That means when you are accessing a table with a single SQL query for single record, then the whole table will be transferred from the database to the application server in the buffer. Now second type of buffering, which is generic buffering. Suppose if you want to access a record from the table, then you are matching the record with the some field through which you want to be execute the query, then this type of buffering is called generic buffering. You may write down, when a record of the table is accessed, all the records whose left justified part of the key is same are loaded into buffer. Now the third one type is single record buffering. Only the record that was accessed is loaded into the buffer. That means if you want to be access a single row, then the database server will load only the single row to the buffer. Then this type of buffering is called single record buffering. So we have mainly three kinds of buffering. The first one is full buffering, second one is generic buffering, and third one is single record buffering. Come to the next slide. Now you can see this is the first kind of buffering. This is called full buffering. Full buffering means that a table is either completely buffered or not buffered at all. In the full buffering, when a single record is accessed, all the record of that table are also loaded into the buffer. That means either you are accessing a single record, either you are accessing a multiple record, then the whole record of the table will be loaded into the buffer. As you can see from this example, this is a database server and this is an application server. In this application server, the client or developer is sending a query. Select star from S counter, where S counter is a table which is stored at the database server, and applying the query with the key field where char id equal to lh and count number equal to 4. Now you are accessing a record with matching the char id, that means matching with the key field, but you have switched on the full buffering, so the database server will not return only the query with the single record with the lh, it will return the whole record to the application server. You can see the whole record is transferred from database server to the application server buffer. Now the buffer will contain the whole record of this database table. So this kind of buffering is called full buffering. Now there are 3 points to be kept in mind while using the full buffering. You may write down about these 3 points, most important points related to the full buffering. The first point, the size of the table to be buffered. Second point, the number of the read accesses, and third one is the number of the write accesses. That means when you will switch on the full buffering for a particular transparent table, you need not to be kept in mind the 3 points while using the full buffering. One more thing that I want to tell here about this full buffering. Generally, when the table size is smaller, then we don't need to be use this full buffering. Then we need to use this full buffering. But when the table size is very large, so we can choose generic buffering or single record type of buffering. Now come to the next slide. Generic buffering. As I have already told you about this generic buffering, with generic buffering, when you access a particular record, all other records whose generic key fields match this record are loaded into the buffer. For example, in this figure you can see, while issuing this query, select star from S counter where char id equal to LH. That means the left justify part of the table of key field is LH. So here the generic key field will be LH. Now in this case of buffering, the database server will match with the key field, and the key field is LH. So in case of generic buffering, note the whole part of the table will be transferred to the application server buffer. Only the key field rows will be transferred to the buffer. You can see from this figure there is a record with the LH, LH, LH and LH, and these type of record LH will be transferred to the buffer content of at application server. Now the third one type of buffering is single record buffering. In this case of single record buffering, we issue a query with the help of single keyword. Select single star from the table name where char id equal to key field and then count number equal to 4. Single record buffering is generally preferred for the record that are accessed with the select single command and the table in which the individual entry are repeatedly accessed. So in this example you can see we are accessing only a single record. So we are this database server is matching with the key field. Key field is LH and another key field is 4 and returning the result as a single record to the buffer content at application server. Now there is an advantage of using the single record buffering because this single record buffering return only the single record. So this can save a lot of storage space in the buffer compared to the generic and full buffering. Generally single buffering is recommended for the large tables in which only a few records are accessed using the select single commands. This was all about the types of buffering. We have three types of buffering: full buffering, generic type buffering, and third one is single record buffering. Now come to the next topic, table buffering. As we have already discussed about this buffering, data access through the buffering and all, this is the same concept we are using here, but the question is arise here. Suppose we have two application server and at the same time they want to be access the same table, then how they will synchronize the database record in their buffers. So repeating here about this table buffering, the buffer always resides on the application servers. During initial access, the data is read from the database. Thereafter, the data remains loaded into the buffer and are accessed directly from it. So, making the database access easier and faster, we use the table buffering. But here question arise, suppose at the same time another program can change this data in the database. So therefore, data must be synchronized. You can see from this figure, this application server is reading the data from the buffer table. So for the initial stage, it will send the request directly to the database server for accessing the database record. Then from this table, scar table, the data will be loaded into the table buffer for this application server 1. Suppose at the same time this application server 2 want to change this data, how the changes will be reflected at application server 1 or application server 2, because the application server has already read this data from the scar table, but application server 2 is changing this particular data. So question arises here, the changes which are going to be done by the application server 2, will this change will reflect to the at application server 1 table buffer? No, no changes will be seen for the application server 1, its common table buffer. So there is a need of a mechanism for synchronizing these data of this buffer table. So this mechanism is called buffer synchronization. Come to the next slides. These slides will describe the process of buffer synchronizations. These slides will tell you the step-by-step procedure for buffering synchronization. Starting with this first slide, buffer synchronization 1, you can see we have two application servers, application server 1 and application server 2. As the buffer reside locally on to the application server, they must be synchronized after any data has been modified in the buffer contents. And this synchronization occurs generally at the periodic intervals in the system profile. So starting with this example, two application server need to access the table scar in the database. The server 1 first reads the record from the table scar on the database. This table is then loaded into the local buffer of the server 1. This local buffer is subsequently used by the server 1 to access the data. Now next slide. Here the server 2 accesses the record from the table scar in the database and loads it into the local buffer. Now you can see the at both the application server 1 and server 2, the buffer content is same. Come to the next slides. Now if a if a user or process on server 1 deletes certain records from the scar table and updates the database, then the server 1 writes an entry in the synchronization table and updates its local buffer. You can see from this example, application server is executing a query delete from scar where char id equal to gl. So the application server will delete this row from this database table. At the same time, the application server 1 will add a record at the synchronization table that the scar table has been modified by the server 1, and also the application server 1 deletes the record from its own buffer content. Now in the next slide, you can see a user on the server 2 can still access the deleted record that resides in its own local buffer, even though they are not longer existing in the database table. You can see this row JL Japan Airlines is existing for this application server 2 buffer content, but actually this is not the part at the database server, which is no longer exists at the database server. So when server 2 will send a query to access a particular record with char id equal to JL, then the buffer content will return the result back to the application server, which is an false entry. Now come to the next slides. In this slide, you can see the problem that was arise, the mismatching or inconsistency among the buffer content at application server 1 and application server 2 that can be resolved with the help of buffer synchronizations. And this synchronization of the servers take place at the fixed time intervals. It may be the interval after the 3 minutes, 4 minutes, 5 minutes or 10 minutes. During synchronization, both servers check the synchronization table to look for any modifications. If they find any modification, then it will update its own buffer content. You can see at step number 9, both the application server are checking for the synchronization at in synchronization table. So when application server will check here, it will find scar modified by the server 1. So In the next step, at application server 2, it will delete its own buffer content, and the next time it will not give the query related to the record that has been already deleted. So therefore it continues to use the table in its buffer to access the scar table. After this table in this buffer is invalidated during the synchronization process, server 2 access the scar table again. Now it does through the database. This scar table from the database is now reloaded into the local buffer of the server 2. This was all about the buffer synchronization. Come to the next topic, and this next topic is decision tree for buffering. This slide illustrates a decision making tree for the buffering table. That means it illustrates the decision making process and help to the client or developer to decide which type of buffering at which time it should be used. You can see, starting with the step 1. Step 1 is start. Now step 2 are temporary inconsistency in the read data acceptables. Are most accesses read only? If it is yes, then table can be buffered. If inconsistency in the read data acceptable is not there, then table cannot be buffered. So now the table can be buffered. That means we have options to choose three kinds of buffering: full buffering, single record buffering, and generic type of buffering. So question arises, is the expected table size smaller than 32 kilobyte? Why you are here asking the questions, this expected table size smaller than 32 kilobyte? As I already told you about these buffering type that can be used based on the size of the table. If there is a table of having large size, then we must not use this full buffering. So we will check here the table size. So expected table size is if smaller than 32 kilobyte, yes, that means the table size is very less, so we can switch on the full buffering. If it is no, that means the table size is larger than 32 kilobyte, then we can either use generic buffering or single record buffering. Now the question arises, is the table access mainly with a select single? If you are executing select single query again, so we need single record buffering. Yes. If it is not there, then is the expected table size larger than 1 MB? Then we need to choose either the fully buffer or generic buffer. If it is no, then we need to be check the key field. If you are using the left justified key field in the SQL query, yes, then you can use the generic buffering with a suitable number of generic key fields. If you are not using the left justify part of the key, generally you're not using, then we will use full buffering. Now come to the practical part. You can switch on this buffering in the transparent table, and this transparent table generally we create with the help of SC11 ABAP dictionary. So we need to open here the ABAP dictionary using the transaction command, which is SC11. So I am entering here SC11, press enter. It will open the ABAP dictionary maintenance screen. Now you need to be select the table for which you want to be on this table buffering. I have already told you about the technical settings, and the technical settings you can set for the particular transparent tables, and these technical settings have mainly three kinds of settings. The first one is data class, second is buffering, and third one is size category. Now in my case, I have already created the transparent table Z employee. Now click on this Z employee, click on the change button. Now you can see in this Z employee table we have created a number of fields. The first field is employee ID, which is a primary key. Second is name, third one is address, fourth one is phone number, and the last one is city, which is as a part of include structure. Now if you want to be switch on the buffering mode, again click on to the technical setting button. When you click on this technical setting button, it will open a technical setting maintenance page. On this you can apply the technical settings. The first setting is data class, that I already told you in the last lecture. Second is size category, you can also choose the size category. The third one is buffering. So we have three options for buffering. Either you can switch on this buffering, either you can switch off this buffering. Buffering is allowed but not switch off, and but switch off. Third one is buffering not allowed. If you want to be choose three kinds of buffering, then you can switch on this buffering part, buffering switch on. Now come to the next part. This is buffering type. We have mainly three types of buffering: fully buffering, generic area buffering, and single record buffering. Now if you want to be choose here single record buffering, just click on it, then click on this save button and activate the technical settings. Now you can see the message activation of technical setting for table Z employee has been successfully. Similarly, if you want to choose another kind of buffering type, just select the particular buffering type and then again click on the save button. Now you can see the generic buffering call for the number of key field is greater than 0. So we need to be selected the number of key fields. As I already told you about this generic area buffer, you need to be specify the particular field, key field on which you want to be switch on the buffering type, generic buffering type. Okay, so you need to be select from here the number of key fields. Similarly, you can select here the fully buffered. Now click on this fully buffered and click on the save button and then activate it. Activation of technical setting for table Z employee successful. Now click on the back button. Check for the error for this current transparent table. Now activate it. Now object has been activated. This was all about the second lesson, lesson number 2 of the unit number 4. Thank you so much for watching my videos.